Hey everyone, I'm Mrdjenovich, and today I'm presenting my 2-scale SolidWorks model of the 737-800 Next Generation. The completed model assembly consists of 51 individual components with 71 total mates. The objects used to construct this model include, though are not limited to, projected curves, 3D sketches, split lines, boundary and lofted surfaces, and features. The aircraft was constructed utilizing dimensions from a 3-view 737 diagram and data found online. In creating this model, I hope to make a realistic and detailed representation of the 737 in both appearance and motion. All the control surfaces in the aircraft move, including the rudder, elevator and elevator balance tabs, aileron and aileron balance tabs, spoiler, and double-paneled flaps. In addition, the front door also moves aside, revealing the interior of the aircraft, and the CFM56-7 engine spins in its case. The motion would not be possible without the use of concentric mates, limit angle mates, and path mates. I decided to run a static simulation to model the stresses on a 737 wing made of 7050 alloy aluminum. After fixing the right edge of the wing, I applied the engine weight of 5,216 pounds to the pylon area, along with an evenly distributed 3,900 pounds for a full tank of fuel. This caused a max von Mises stress of 734 psi and a max displacement of around 1/8 of an inch. The most challenging parts of the project were accurately modeling the curvature of the fuselage and modeling the motion of the flaps using path mates. In its entirety, the project took over 100+ hours of research and construction. After this long trial, let's take a look at this beautiful aircraft.